Okay, so lecture number 2, week number 5, and today we'll be looking at this very useful topic, which is called composition, right? So, as the name suggests, we are trying to compose something, right? Composition is from the word compose, right? So, what it is from the perspective of programming and more specifically object-oriented programming. So, you see, if you look the real world objects around you. So complex objects are actually built from simple objects, right? For example, if you look at car as an object, car has a frame, an engine, maybe tires or steering wheel and so on, right? So all of these you put together and you make a complex object which is like a car. Similarly, if you take an example of, say, an object which is personal computer, so you can say, okay, a personal computer is basically a combination of a CPU, a motherboard, memory, hard disk, and some devices, right? So you see, using existing objects, you are trying to make a relatively more complex object, right? So if we say, okay, if I have to build a car, maybe these are all the components of a car, right? I can put them together in the correct way and I can actually end up with a vehicle, okay? So the formally, when we are trying to build complex object from simple one, it is called composition, right? Now what does that mean? In order to understand that, maybe we do some discussion in detail. That you see, you already have some classes, right? For example, you have seen classes in our previous discussion. We have seen a class for time, I think date, point we have seen many times, right? And so on. Okay, so you see, when you are making a relatively complex class, it makes sense to reuse your existing classes, right? Now what does that mean? We also talked about a class, say student. Okay, so when we say student, what are the attributes of student? Maybe an enrollment number, a GPA, and a date of birth. Now you see, date of birth. What is actually date of birth? It is a date. So if I will see, do I already have a class which I can reuse for this date of birth? Yes, I already have a class for date. So somehow I will be reusing this class in the student class so that I don't have to rewrite all the functionality of a date class in student because I need a date of birth, right? Similarly, you see, let's take another example. There's a class called flight. So flight has a departure time, an arrival time, right? Similarly, a departure date, arrival date, and so on, many other attributes, right? So you see, if I need functionality of a time, hour, minute, second, which I should be able to change, I should be able to update because flights may be delayed and so on. So I will see, do I already have a class? Yes, I already have a class time. I already have a class date. So I can reuse both of these classes in the flight class so that I don't have to write all the code again, right? And now you see, whenever we are doing some examples or whenever you are doing some assignments, so I always ask you that whenever you are making a class, it should be it should not have any extra functionality which is not related to that class. For example, if you are making a date class, it should only have the functionality of a date. It should be so clean that you see the same class you can use in student and the same class you can use in flight, right? So I will not make two separate date classes. It is one single class. Similarly, the same can be used in exam. If what is the start time of exam, what is the end time of exam. So that's why whenever we are making classes, we have to be careful, we have to think big, that it is not only going to be used in the example which I am solving. My class should be so crisp and clean that if it's a date class, then any application which requires a date, my class should be reusable, right? So this is the whole idea. And why do we focus on reuse? That you see that suppose you are studying mechanical engineering and someone says, okay, you have to make a car which is fuel efficient. So if you have to make a car which is fuel efficient, then you will not start inventing the tire or making the seats or the frame. You will buy all those components from the market, right? And you will only focus on the engine because you have to design an engine which is consuming less fuel. Other components, you will not start making a tire or frame or steering. You will simply buy them from the market, right? So what you are buying from the market is actually reuse. So if you have already have date time classes, you will reuse them in whatever class you are making, right? Now, in order to formally discuss this idea, and then I'll explain you again what is composition. So let me just write a concrete example, right? And then we'll come back to formal definition of what we call composition. Okay. So let me make a class, say date. Okay. So I'll write class date. And what do we expect in a class which is modeling date? Date is modeled by day, month, and year, right? So we'll have three data members, day, then the second one is month. Okay, sometimes month you can take a string like the name of the month, but it's easy if you take it integer. Okay, and then you have year. Okay, so these are the three data members. And then in the public section, maybe I don't write everything. You can assume there's a print. Okay, I'll write just two functions. Okay, one is the constructor and other is a print function. So constructor of the date should have, I'm giving it some default values. Month is 1 and year is say 2020. So that if user does not supply any values, we get the default value. So day gets the value D, month gets the value M, and year gets the value Y, right? Similarly, you can have a print function in the class, which in which you have like cout all the three data members, right? So I'm not writing it. You can just assume I'm just void print, and you can assume that here you have three cout statements, which are saying cout day, month, and year, right? So that's it. Okay. Now, suppose this class is there. You have already written it. Now someone says, okay, you also have to write a class student. And what do we need to store for a student? Enrollment number, GPA, and date of birth, right? So when I come here, I see, okay, what are the data members I require? Enrollment number, which can be an integer, no problem with that. GPA, which can be a float, straightforward. Now, when you think, okay, for date of birth, what should I do? You have two options. You say, okay, I need to store the date of birth of the student, so I can take three integers in the student class. I can call them day, month, and year, right? But you see, you say, okay, why not somehow reuse this functionality which is already there? Instead of having three integers here, say day, month, and year, uh, why not do something better? And if I already have the date class, somehow reuse it. Okay, and how can you reuse it? Once you have created the date class, now it is a data type which you have created. So just like you are taking integer float, now you can take an object of date class in student class, right? Date, which is the data type, and object is DOB or whatever you want to call it. Now, before we move on, let's discuss this. Okay, so this is the actually key part which is new. Now, what we are doing here, object of one class is member of another class. Like object of date is a member of student class. So you see, when I showed you the introduction in the beginning, we say you are making a complex object from simple object. So student is the relatively complex object which has an object of another class which is date. So this actually is composition, right? If you don't do this, if you have three integers here, then there is no composition. So in simple words, composition is simply when you are using object of one class as member of another class, right? So this student class is actually called a composite class. Composite class. There are other terminologies as well. For example, since student is having date, right? So there is a very common terminology which we use with composition, which is called has a relationship. You see, because now you have two classes. One class is date, and the other class is student. Now, in this case, what is happening? Student has a date object, right? So there is a special notation for that, but I'll show you that in a while, not immediately. So I'm just connecting them by a straight line. So you see, student has a date of birth. So this is one class, this is another class, which is containing object of the date class. So this student class is a composite class. It is also called container class. Why container? Because it is containing date, and this date is called contained class, right? So this is container, this is contained. Container mean which is having an object, right? So I'll come back to this conceptual discussion in a while, but so far, what is the summary? Composition is simply when you have object of one class as data member of another class, and the class which is container, for example student, that is called composite class. Okay, composition is called has a relationship, right? You see, student has a date of birth, flight has a time of departure, similarly exam has a time of start, right? So in all of these cases, whenever we are making, you can say, or designing something, we can always think that how I would represent this relationship in real life, right? So if it has a something is having another thing, then it means you can model it by composition. So now let's go back and try to complete this class before we come back to our conceptual discussion. So now there are two important things which I will write in this class. One is the constructor, and other one is maybe a print method, right? So now you see the constructor would be exactly the in a similar fashion, but maybe it would be slightly different for you. So let me just write it. So this is the constructor of the student class. Now what are the data members of the student class? Integer, float, and a date object. So it means these three should be input to this student. Okay, so what I can write? I can write some int e, maybe some float which I call g, and the third argument is actually an object of class date. And we have already seen that since it is a data type, so just like you pass any other integer or float or character, you can also pass an object, right? So within the body, again nothing special, just three assignment statements. So you can write this, and similarly GPA gets a value G, and we have already seen that assignment operator is allowed on objects, so you will write like this. So now see, this is the constructor, because the only you can say slightly new concept is that here in the constructor we are passing an object, and but that is perfectly legal, we can pass it to a function. And the reason was that whatever we have data members in a parameterized constructor, we actually pass those whenever you are trying to set the values of the data members. Now I'll make one more function in this class student before we actually write this program and see its output, right? So maybe I'll just get rid of this date class. You can assume it is there. Okay, so I'm just getting rid of it to have some space. Okay, so maybe we now write a function, say print function in this class. Okay, so now this is the function within the student class. Okay, so suppose I write the function print. Now what is the objective of a print function? We know print function should display the data members, right? So how can we do that? It's fairly simple. We can write cout GPA enrollment. Right? Now a common mistake that many do is the temptation to write this. Okay, so maybe our first two statements are okay, there's no problem with this one, this is okay, this is okay, but you see there's a problem with that one. Why? Because we discussed you cannot use cin or cout with objects of your classes, and it is same for the structures, right? When you create your own data type, you are not allowed to directly use C out or C in. Now, what should we do? There are different ways you can actually do that. But if you remember the date class, in the date class, we made a function print in which we write cout day, month, and year. So why not reuse that function? And how to reuse that function? Just like you call the function in the main, object dot name of the function. So you see, previously we have been writing these statements like this in the main, right? But now, since I have object inside the class, so I can perfectly call any function of that class using dot operator and object name, right? This was my variable name dob. So using this dob, if I want to print the date of birth of a student, then I can simply call dob.print and it will actually print it. Of course, there are other ways as well. If you have the get functions like get day, get month, so you can also call them and write cout here. But please do not do this, okay? Because maybe if you are doing on a computer, it will give you that it will not compile, so you will realize that it's an error. But when you are writing on the paper, maybe in an exam, so there in hurry or due to lack of concentration, quickly many students actually rather not a very big percentage of students just write like this, right? So be careful. We cannot do it like this. We'll have to call a member function because we cannot use C in and C out with objects of classes, right? So let's make this example, the same example, right, with more details on the compiler, and then maybe we can discuss further. Okay, so let me uh, open the compiler, and here we'll try to make the same, you can say, program with a bit of more details, right? Okay, so I'll first make the date class. So class date, okay, and we have three data members: day, month, and year. Okay, so now we make the constructor and some other functions, right? So when I was writing on the board, so we actually had limited space, so I did not make all the functions, but here we'll be making all the required functions. Okay, so let me quickly make, say, date. Okay, I just make two constructors rather than one. So I say day is 1, month is January, and year is, say, 2020. This is the default constructor. And then I say int day, int month, int year. And within this, I can copy all the past values within the data members. Okay, now maybe you can also make some set functions, get functions, right? But let me just make at least the print function. Call it, say, print date. And here I can write, say, day. And then month. And finally, we print the year. Okay, let me quickly just compile and see if it's fine before we make the complete program, right? So it's a good idea when you are making a program, just write a little and compile it. So if there is some error, it can be easily tracked, right? So it's fine till here. Now I go on and make my second class, right? So this is the date class, which is already there. Now I will make the student class, say, class student. Okay, now within this class, let's see what we have. We have, say, private integer enrollment, a float, which is GPA, and date, which is date of birth. Now this statement is the key statement because this is actually composition. When you are taking object of one class as a data member of another class, right? So the key statement is this date TOB, which is making it an example of composition. If I don't use date, I use three integers here, then this is not composition. Okay, so let's now make constructor in this. So I say float GPA and JD, and quickly you can copy these values. Okay, so GPA is GPA, and okay, so this is a constructor. Now we make the maybe a print function, right? Void print student data. So I write cout what is the enrollment number. So I simply print it. What is the GPA? Again, we simply print it. And now is the important stuff. You see, if I write cout DOB, okay, so you see it is giving me an error. It is giving me an error because you cannot directly write you see to see out or see in with objects of your classes, right? But what you can do is you can write say dob dot. So you see dob has a member function print date. When I write dob dot, it is giving me a suggestion that I can call this function. So I can call this function. And now what will happen? When I call this function, it goes to the date class and it prints the three data members which are here. Okay. Another thing which you can do is that suppose which is not recommended, but just that you should know that this is also possible. I can make get functions here, get day, return day, get month, return month, and get year, which says return year. Okay. So another thing which you can do is you can here write cout, right? For example, if you want to print the year, so what you can do, you can write dob dot get year. And similarly, you can print all three data members, right? But you see, if you are doing it, it is syntax wise correct, but it is not a smart choice because you already have three cout statements which are printing a date. So rather than again using three cout statements here by getting the value of day, month, and year, you will have to rewrite three cout statement, which is not smart, right? Because in this example, there are only three data members, maybe something which has 10 data members. So it's a good idea. Instead of this, you simply call the print method because we already are printing the date of birth in that. Okay. Now let me write the main and then we see the output of this program, right? So you see, when you want to create a student object, right? If you want to get data from the user with cin, please do it in the main, right? You should avoid having cin within the class. Okay. Of course, it is syntax wise, it is fine, right? But as I keep telling you that cin is only one way of getting your data. There are situations in which you can get data from a file. You can read data from a file and pass it to a student object. So if you're doing cin within the class, then your class cannot be reused if you want to read data from a file. But if you are doing cin in the main, the advantage is that the same class will work even if you are reading data from the file. You will just change your main. You will not have to change your class, right? So this is the advantage. Anyways, so I'm not doing cin here, but I'm just writing values. So this is the enrollment number, say 151. This is float GPA, which is say 3.5. Now you see, when I will create an object of student, I also need to tell date of birth when I call this constructor. So before creating an object of student, I will need to create an object of date, right? Which is actually the date of birth of the student. So the date of birth is like say 2nd March 1995, something like that. Okay. Now we have enrollment number, GPA, and date of birth. So now we can create object of student. The object of student, it needs three inputs: integer, which is the enrollment number, GPA, which is a float, and the third input is an object of class date. So we have already created an object of class date, which I can pass here. Okay, and let's just try and say print student data. So we expect that when we call this function print student data, it should print the enrollment number, GPA, and date of birth of the student. Okay, so let me just see if this program is okay. Let me compile it, and if it's fine, we can maybe see its output. So let me just run it and share with you the output screen. Okay, so I hope you can see the output screen. We have created an object of class student, so we call the print function. Now you see enrollment number, GPA, they are printed, and then you see day, month, and year, 2nd March 1995. And why? Because from the print function of student, we called the print function of the date. So the last three statements that you see here, they are actually coming from the date function. Now let me go back to the code and correlate this information with the information that you see on the screen. So this is a code. Okay, now let me just explain again what was actually going on with some annotations. So just give me a second. Yeah. Okay, so this was our date class, right, which has a print function, and this is the all important part, which is our student class, right? So when you are doing this you have already been doing. The special or the key part is this. So this is actually composition, right? And when we make the constructor of the student class, so we have one integer, one float, and we expect one date object. And this statement is legal because we have already seen that assignment operators can be used with objects. So there's no problem with that. Another key statement in this whole program is this one, right? Because when you have to print enrollment number and GPA, you can directly use cout because they are primitive data types. But when you have to print date, date is an object, and you cannot use cout with objects of any class, right? So this is something that you are not allowed to do. But you already have a function in this class, so you can call this function. Previously, we have been calling functions like this from the main, but now since I have an object in the student class, so it is perfectly fine. I can call this function from within this class. Okay. Now in the main, the important part was that before we could create an object of student, it needed three inputs: enrollment number and GPA, but it also needed date of birth, which is an object. So it means first I create an object of date, and then I create an object of student. Okay, and composition, as I told you, it is called has a relationship, right? Because student has a date of birth, right? Similarly, flight has a time of departure, exam has a time of you can say start, employee has a date of joining, right? And so on. So this is the complete example. Let me just clear this, and then we can maybe discuss. Okay, now before we see some other examples, let me now formally tell you how do we represent composition in UML, right? If you remember, we draw a rectangle for a class, right? Here you have data, and here you have functions, and here you have name of the class, right? So name of our class is student. Previously, the programs we made, we had only one class. Okay, so we just made like this, and that's it. But now, today, from today onwards, we are making programs in which we are likely to have more than one class. Okay, so this is our date class, and here you will have data. I'm not writing it, but you will write three integers, and here you will have function. Now, since these classes are somehow related, and they are related by a has a relationship, so composition is represented by a symbol which is like this diamond, filled diamond. Okay, this is a diamond symbol which actually represents composition. And where do you put this diamond? You put this diamond on the container class. That you will put this diamond on this side. You will fill it whatever color you like, and you will connect those classes. So this diamond symbol is actually the UML notation for composition. And how do you read it? You read it as student has a date, and date is actually date of birth, right? So this is how you read it. Student has this date or date of birth, whatever you want to call it, right? So now whenever we'll be making some programs, right, before writing any single line of code, first it's a good idea that you draw UML diagram so that you know how many classes are there, what are the data members and what are the functions, right? Today there are only two classes. Maybe 2 weeks later you will have a program which will have six classes. And composition is only one type of relationship. There can be some other relationship as well, which we'll see in the subsequent weeks. So you see, eventually you will have a very good visual illustration of your program or your design, and then you can convert that design into a C++ or Java or whatever programming language code you want, right? Okay, now this is the same example in your slides, right? A little bit more formal. So you see, we have the date class, and in the example that we have in the slides, I have intentionally put the definitions of the function outside the class, right? Because when we are discussing on the board, we have lesser time, we have lesser space. So I just write everything within the class. But as I keep telling you, it's a good practice that in the class you only give the prototypes of the functions, and the definition of the functions you give outside the class. Okay, so again the same example, a quick recap. A constructor, a print function, you see we made it constant because we don't want to change data members. You can say three data members, then this is your constructor, and then this is your print function, and finally this is not required, the destructor, but just if you want to practice you can simply put a cout statement here, so that when the program terminates you know that memory is released and object is destroyed, right? Although it is not doing anything useful, so you can skip it as well. And then we have this employee class. Rather than student, we have taken a different class, employee. And within employee, what are we storing? ID, date of birth, and hiring date, that when did this employee actually join. Okay, and now you see you have two objects of date class within employee class. This is what is composition, right? These are the key statements. Now when we make the constructor of employee, what it should have? One integer and two date objects. So you see, integer, date, and date, because there is a date of birth and there is a date of hiring. There are two date objects, right? So that is perfectly fine. We can have multiple arguments to a function, and then we have a print function. So this is the constructor of the employee. You must have noticed that the body of this function is empty. Why? Because in this example, I have used the other syntax of constructor, right? If you remember the other syntax of the constructor, what we used to do was we write like this, then we put a colon, okay? And for example, in ID, I want to pass this value E. So this is same as writing ID assignment operator E, okay? So it's up to you, whatever syntax you like, but don't be confused that what are these things. This is simply saying, for example, this one is simply saying birth date gets the value date of birth, right? So this is just the other syntax of constructor, which you can use if you don't want to use the assignment operator. If you find it tricky in the beginning, you can stick to the assignment operator. And then this is the print function in which we print the ID was an integer, so I can directly use cout. But the other two data members, date of hiring and date of birth, since they are not you can say primitive data types, so I cannot use cout with them. So I am calling hiring date dot print, which will print the date of hiring, and birth date dot print, which will print date of birth, right? And one important thing is, I'll go back to the class and explain, which is again related to design rather than you can say anything else. Okay, so you see this is a print date function. Now suppose you I ask you, I give you this task as an assignment, right? So many students have the tendency to do that. They would write here cout date of birth is, and then they will write like this. Sorry, I missed a semicolon. Yeah. So you see, it is perfectly fine. There's no problem with that. But now you have a constraint. Now you have assumed that since in the assignment I ask you date of birth, you put this statement date of birth is in this print function. So what if someone is using this for date of joining or date of admission, right? Suppose if it's a student class, I gave you that, okay, student has a date of birth. and you have this print function and you are writing this cout statement here, which is okay. Your assignment is solved, everything is perfectly fine, well and good. I ask you to change your student class and also add date of admission, DOA. So now when you will call DOA.print, so what will happen? Someone will see date of birth, this statement printed, which is not correct, right? So you see, if you are putting a statement like this in your class, you are actually restricting the generalization of your class. So that's why I keep stressing again and again that you should only write date or simply print this. And if it's a date of birth, you should have this statement when you are calling this function rather than within this function. Because if you do it within this function, then what if instead of date of birth, I also have a date of admission, I also have a date of degree completion, and what if I also want to use the same date class in a flight class? So it means if I will ask you print date of flight, so this statement date of birth will be printed, which would be meaningless, right? So this is very important that uh, whenever you are making your classes, they have to be clean in a sense that they should be reusable by different multiple composite classes. Okay, now before I show you some other example, I'll discuss something conceptually that you see there are different types of you can say composite classes which we can have, right? Now, first we go back to our example of student and date. So you say this is your student class, and then you have a date class, right? And we say it is composition, so I represent it like this. So we say student has a date of birth. Well and good, right? Now just look at the bigger picture. Suppose you have a data of all the students in the class, right? So maybe I have record of all the students, and record means name of student, date of birth, GPA, right? So now we have these are all the students in say 2A or the complete university, whatever it is, right? Suppose there is a student who withdraws or cancels his admission, means he moves out of the university, right? So what we'll do, we don't need the data of the student anymore. Maybe we keep this data for 1 year and then we say, okay, now we can delete it. So if this was the student who left the university, so this is deleted from the database, right? This is how things happen. Now just see, when you are deleting the student, right, this student, his all the data is gone, means his date of birth is also gone, his enrollment number is also gone, his GPA is also gone, right? Because you have removed all the data of this student. So what is actually happening is, when the container class is deleted, right, when student is deleted, the contained class is also deleted, right? By class I mean the object of the class. Okay, of course the code of the class will stay there. So when you delete the container object, for example, when you delete a student, you are deleting complete record of the student. It is not meaningful that I only keep his date of birth, right? जब student ही नहीं है तो उसकी date of birth तो हम नहीं रखेंगे. It makes sense. So technically I can say, when container class object is deleted, the contained class object is also deleted, right? So this is called strong has a relationship, right? The keyword is strong. Why strong? Because when container is deleted, the contained object is also deleted. This is called strong has a relationship, and this is actually what we call composition. There is a variant of it, right, which is again a design level change. In the code nothing will change, right? Code will be exactly what you have been writing. Now let me give you another example. Suppose you have different you can say students who are enrolled in different courses, right? So there's a course, right? Suppose a course is offered, say what is the course, say DSA, okay? And we say in this course we have 20 students, so I can take an array of 20 students within this course class, right? Because it has 20 students or maybe 10 students. When this course is offered, you will register, students will register. So you can say that course has students, which makes sense, right? Because in a course we are keeping all the data of the student. Now let me just visually draw it and then we discuss. So there is a course class and there is a student class, and you can say course has students. So this is course and this is student. Okay. Now student has all the data, date of birth, enrollment and anything. So now we have data of courses. That this is a course, in this course, which are the students who are enrolled. This is the course, which students are enrolled, right? We normally keep this type of data. Now suppose at the time of registration, you know that if there are very few students in a course, it is not offered. Okay. So we offered a course B. There was one student, two students, three students, and then no one else registered. Okay. So what will happen? Since this course was not offered in spring 2021, we delete this course from our database, that this course is not offered. Now, when I delete this course B, do I also delete all the data of the students? No, the data of the students will remain because those students are also enrolled in some other courses, right? There's a student say XYZ, so maybe he's also enrolled in this course A. So if a course is deleted, I will not delete the data of the students because students are enrolled in other courses as well. So what is happening in this example? When you delete the container class, which is course, the object of the contained class is not deleted because this object is, the student is enrolled in other courses. And this type of relationship is called weak has a relationship, right? Weak has a relationship. Why it is weak? Because the container object is deleted, but the contained object is not deleted. And when you represent it like this, but this time the diamond is not filled. This is an empty diamond. And strong relationship is a filled diamond. So you see, it's very similar concept, but just a minor difference. And please, I'm recalling you again, this difference is only, this is not in the code. When you write the code, it will be exactly C++ code will be exactly the same, right? But at the design level, a filled diamond is a strong has a relationship, and empty diamond is a weak has a relationship. I can give you another example of a weak because I understand it is not very easy to follow. You see, every year we have different leagues in which there are players. Okay, so suppose there is a team, there's a database of all the players, right? Maybe all the cricket players in the world. There is a database, Cricinfo, you all know, and there is a database of all the teams. So team has players, right? Maybe every team has say 15 players, some reserve, and so on. So suppose after a few years, the owners of a team decide that okay, we are dissolving this team. Okay, we will not, this is not giving us any benefit, any profit, so let's get rid of this team. And there is some team in any league which is dissolved. So when that team is dissolved, you say okay, just delete all its data, we don't need it any longer. Will we also delete the data of all the players? No, those players will join some other team, right? Maybe even if they don't join at a later stage, they can join other team. So team has players. This is again an example of a weak relationship. On the other hand, there's a say flight. Flight has a time of departure, time of arrival. The flight is cancelled, we delete it. It is not displayed on the board, right? You go to the airport where you see the schedule of flights. If a flight is cancelled, you say okay, let's delete it, it's no more there. So when the flight is deleted, you will not see its time, right? Because it does not make sense that when the flight is not going, why will we display its time? When the flight is gone, the time of departure is also gone. So that is again an example of a strong relationship. So strong relationship is actually called technically composition, and weak relationship is called aggregation. Okay, all this information is in your slides, don't worry about these terms. So normally we use the term composition, we rarely use this term aggregation, but I'm just telling you that when you go to the advanced semesters, you will study software design. So at that point in time, they will they will actually tell you in detail the difference. But since we are studying composition, so I thought it's a good idea that you should also know from the design viewpoint that strong relationship is called composition, weak is called aggregation. but when we'll be writing a program, we'll not be distinguishing. Okay, so I will not be using the term aggregation. I have just told you this so that you know in one of the future semesters, when you hear this term, you can recall that we studied it somewhere. Whenever we are doing something, I will always be using the terminology composition. Okay, now let me with this we can maybe take a quick one more example so to better understand how composition works. And a very good example is basically from the circle class, but I'm intentionally not doing it because since you are doing assignment on it, so if we discuss circle class, it may confuse you, right? Because we can include composition in that class as well. So I don't want to confuse you because then maybe you get a bit confused that how and you make some mistake in solving the assignment. So that's why I'm not giving you that example. Let's do an example which is like say a rectangle class. So this is a rectangle. Okay, and this is x-axis, this is y-axis. So we say when you have to draw a rectangle, there are different ways, right? One way is that you tell this top left point. Okay, this maybe point is 2 4. Okay, and you tell the bottom right point. Say this point is 8 and this is like 2, so this point is 8 2. If I give you a graph paper, I say the top left is 2 4, bottom right is A2. So you should be able to draw this rectangle on the graph paper, right? So these are the two pieces of information you need. There is another way. I can give you only this 0.24. I can tell you the length and the width, still you can draw it, right? So it means at least you should know one point, and either you should know the second point or I tell you the length and width and you should be able to draw it, right? Now let's see if I have to, let's stick to this convention where we are using the top left and bottom right point. If I show you this illustration and I ask you, okay, implement it in C++, okay. So you see one possibility could be you say, okay, I will make a class rectangle. I have 4 integers, so I call them x1, y1, x1, y1 for this one, top one, and x2, y2 for this bottom point. It is pretty much okay. You can do it. But can we do something better? If you remember, yes, we can. You see, from day one, we have been repeatedly making a class which we are calling point, which has two components, x and y. So top left 2 4 is a point and bottom right a2 is also a point. So why not we reuse our point class in making a rectangle, which is a good idea. So you see, this is something that we have been doing. This was the reason we were repeatedly looking at that point class. So you already have that point class. Now when I make the rectangle class, I will write class rectangle, and instead of taking 4 integers, I can say one point which is top left. Okay, so I'm talking about this point. Similarly, I can take another point which I call bottom right. Point bottom right. So it means for this point. So with that, what we can do is, now this is composition because we have object of one class as data member of another class, right? So this is a better design. Of course, if you take 4 integers, still you can solve the problem. You can make the rectangle class with all the functions, but this is a better way of doing it, right? Because we already have a point class. We will have functions in that class to set, get, and display or anything else, add points just like we did. So why not reuse it, right? So this the whole idea is reusing this class. Now let's quickly write maybe a few functions in this class, maybe a constructor first. So now this is the constructor. Now you can see the constructor will have 2 points as input. One is the top left, the other point is bottom right, and within the body you can write simply top left gets this value, similarly bottom right gets other value. And once you will be making the display function in this class, okay, so that is also important. I'm repeating it because so that you don't repeat the mistake of writing C out top left, C out bottom right. So when you make the point class, we assume you made a print function in that. So if you are making the print function in the rectangle class, you will write void print, and here you can write top left dot print, which will print this 0.24. And similarly, when you want to print the other point, you will write bottom right dot, and you can call the function print, and so on. Similarly, you see, if someone asks you how can you calculate the width of the rectangle, right? Because in this current version we don't have width, but you can make a function. What is width? Width is actually, or height or length, whatever you want to call it. So maybe I call it width, and I call it height, which is h. So width is 8 minus 2. Okay, and how do you compute 8 minus 2? What is this point? You are actually subtracting the x coordinate of, you can say, top left from, sorry. So you are subtracting 8, which is the x component of bottom right. From this 8, you are subtracting 2, which is the x component of this point, which is actually top left. Since these data members are private, you cannot write dot x dot y, but you see, we always make get functions in the class for exactly this reason. So I'm not writing the exact code, I'm just giving you a hint. We'll do this example, complete example next time, but I'm just giving you a hint that if you have to do this 8 minus 2, so what is 8? 8 is bottom right dot, I cannot write x, but I can write get x. Why? Because x is private. So this will give me 8 minus, how do I get this 2? This 2 is actually top left dot get x. So when you do this, you actually get the width, whatever you want to call it. Similarly, you can subtract the y components and you can find the height. Okay, if you don't want to do much calculation, bottom right, top left, which are these, you can simply subtract anything from anything and take the absolute value, right? So that you don't have negative value. There are many ways to do this. And if someone asks you what is the area of this rectangle, you first compute width, then compute height, and then you can multiply them, which will give you the area, right? So this is, you can say, this is just giving you hints. Don't worry, I'll solve this complete example. I'll show you the output, right? And maybe we'll also have a similar program in your lab session as well, right? So don't worry about it. And let me just get rid of this. So you see, this concept of composition is fairly useful. Just like we made the rectangle class, we can make maybe triangle class. And what I did not tell you is that when you are making a circle class, okay, so circle has a center which is xy. You can also take that as a point, right? Although it is not required in your assignment because we did not see composition at that point in time, but I'm just telling you that maybe if you attempt the same problem in week number 6, so rather than taking int x int y, you can make a point class, and then you can use composition. That center of a circle is a point, so you can reuse the point class, right? That is another possibility, right? So with that, maybe I'll stop. If you have some queries or comments, we can discuss those.